So key components for this course, no, we'll be discussing, of course, yung mga data flow, no, for edge devices na sila pumupunta. Basically, it's gonna be from yung mga IoTs o yung mga sensors natin or cameras, no, sending to a edge gateway. This is an optional, no, feature, but let's say for a fully autonomous car, no, you don't. It's an example of an edge computing device. It connects to the cloud environment, but you don't want your data to be sensed habang tumatakbo ka ng 100 kilometers per hour, no? And then i-upload sa cloud to process kung may tao ba dyan sa harap ko or wala, no? The latency might not work by that time. Baka nasagasaan mo na yung tao na bago maka-respond, no? So, on those extreme cases, no? Or it's not gonna be extreme, sometime soon, no? It's gonna be regular. You want that processing to happen near the equipment. So at least for those autonomous vehicles, no, they have edge gateways where sensors could pre-compute those data or ask the help of edge gateways, pre-compute there, and then decide on their own, no? And then just submit telemetry data dun sa cloud nila or edge data centers. No? This also makes it less work, no, sa mga cloud environment and edge data centers kasi they don't have to pre-compute, no? They're just waiting for the result of the processing that happened on the end devices, endpoint devices. But ultimately, they have a holistic view, no, ng lahat ng entire fleet, let's say for an autonomous vehicle, dahil lahat ng machines, no, nagsisend ng telemetry sa kanila, and they could make some decisions, no, business or operational, based on those information. And they could push that decision, balik dun sa mga edge gateways and eventually to edge devices, no, to recalibrate the infrastructure. No? And we'll see that in a bit. Okay. So edge devices, these are physical devices or sensors that produce, collect, process data, and process data locally. These devices, pwede siyang smartphone, laptops, cameras, IoTs, industrial equipments, no, robots, drones, or autonomous vehicles. No? They have built-in processing capabilities. No? We enable them to perform basic data analysis and filtering before sending data to the next stage, no? Or on the edge computer architecture. So basically, what you want is reduce the amount of data transmitted, no? And minimize latency. So pushing compute capabilities to the edge helps with this one. Okay. So edge gateway. This is an optional component of cloud computing, although, well, key component siya, no? But it depends on your deployment. No? If there's a large amount of sensors within that area, edge gateway would be the way to go kasi again, parang yung CDN example natin kanina, no? Mas mabilis makakapag-ask ng resource, no? Yung mga sensors natin and edge devices to an edge gateway kasi malapit lang sa kanila to. And the edge gateway could have more power, no? Speaking kasi most of our edge devices would be operating on a limited capacity, especially kung wireless just or and off the grid, no? But wireless siya with battery power, battery operated, no? Hindi enough yung compute power niya. But edge gateway is typically powered to, no? Na near yung mga sensors, so they would have a boost in compute resources, no? So all of these sensors and IoTs, no, would be sending information kay edge gateway, and pwede si edge gateway mag-pre-compute or secondary computation or processing, no? I mean, the IoTs already pre-processed yung mga data nila. But pwedeng may regional or local view, no, si edge gateway kung ano nangyayari within a short geographic distance from his location, pre-process that, and then submit that I would say mashed, hindi naman mashed up, no? Parang filtered information dun sa cloud environment ng component ng edge gateway. Again, some features that of course is additional functionalities like compute power, Protocol translation, no? Because maybe the end sensor devices natin aren't talking TCP/IP. For IoTs and operational technology environment, usually mga Modbus yan or SS7, no? You could send data kay Edge gateway, and then Edge gateway would talk to the Edge servers, no? Or cloud servers via TCP/IP. So that's a protocol translation. Could also do data caching, some security features, and local storage. No, if you're, let's say, sensing via video, no, ano tayo, computer vision, no, you might not want to submit all that data to the cloud, no, for processing, kasi that would take a lot of bandwidth, no, and storage, no, on the cloud for that matter. You could send it to an Edge gateway. Edge gateway would pre-process it, and then may nakita siyang anomaly or out of scope, no? They could trigger an alarm, but yung alarm na lang na message yung isasabi sa cloud. You don't need to have yung full na video, no, feed to be sent to the cloud, and this makes it more efficient. No? Of course, hindi always, no, but some host edge applications, no, may require more computing resources than available to the device itself. Again, some would be battery operated. And when you do design an infrastructure like this one, no, you do compute for battery consumption. Let's say kung battery operated ka pero may solar, no, you want that battery to be charged in the morning and then used sa gabi. And then may enough capacity ka that would last you through the night until pumutok ulit yung araw, no, for you to recharge. No? Or maybe you have 2-day cycle, no, na enough yung battery for that in case may bagyo or umuulan. What affects those battery usage, of course, is computing. No? If you are always na high capacity compute na naka 100% lagi CPU mo on the edge device, it's gonna consume more battery than usual. Kasi dapat naka low power mode siya pag wala siyang ginagawa. No? So, what is consuming a lot of CPU resource? Data processing, security also, diba? Encryption, it is heavy on math. And I've seen OT environments where they are forgoing encryption because they need it to be responsive. Security adds a bit of a latency, but they need it to be responsive, and they need to conserve battery. No? So they are opting not to encrypt some information. No? So may issue with security, and then just submit it to an edge gateway, and then that edge gateway would be the one that's secure enough to talk to the servers, no, for telemetry data. Of course, we have edge data centers. These are yung localized, no, smaller scale data center. Basically, if you could just imagine, no, nagtitiring ka from edge device, may edge gateway ka, na meron kang edge data center. Again, you're trying to process the data as near to the source as possible. And yeah, this is still within local geographical region, no, near your sensors. No? Likely talking, kung hindi man diretso from the end devices, mga edge gateway yung kumokonek sa kanila for processing. But typically, mga data analytics and telemetry na dito, unless kailangan mo talaga i-push yung, yung raw data, no, for some other processing requirement. And dito ngayon, nagli-link with cloud computing. No? You still need cloud computing to centralize edge computing infrastructure. Again, edge computing is there to support, no, and augment yung lack of processing power if you're just using cloud, no, kung nasa edge terminals lang yung source mo, no. So you would be, again, yung old school cloud, no, send all the data to the cloud and have it processed. It's not working for large scale deployment, no, ng mga nodes. It's gonna be very costly for you, but you would also consider, no, pag naglagay ka ng compute power sa mga edge devices, may cost din naman yun. Diba? Yung CPU niya, yung memory niya, yung storage niya. No? So, you need to mix and match, but at some point, it's really yung time sensitivity of the task, no? Yun yung, well, wala kang choice sa cost or otherwise. No? Kaya mas mahal yung edge computing kasi you need compute power there, or you could really process the cloud would have latency. See, edge device, compute it there, minimal latency, no? Kasi, di ba, na-sense niya, kinompute niya, then nag-decide kagad siya on its own. So, yun yung benefit nun. That's one of the non-negotiables on when to use edge computing. You need low latency. And again, hint, Open Run would require low latency for a lot of it, a lot of its processing needs. No? And that's the infrastructure, no? But of course, you need applications, no, and analytics to run. So these are yung mga data processing and analysis performed on the edge devices or the gateways or the data center. This is where you tie it up all together in software. So some, again, some data na you grab and collect, you could process it and then have the endpoint no, decide on what to do based on those information. But send some of those data to the edge gateway or even just telemetry data. No? Again, you design it in such a way na you are using no, edge computing and cloud computing on when where they are very ang term doon, saan sila magaling to speak na. So but yeah, again, edge computing though, ang view lang nila would be on their own environment. That said, no, they could get feedback from edge data centers, no, edge gateway, and any information that they have, if it's required within the system, no, they would submit those telemetry data to the centralized, most likely via cloud environment.